Okay, so I think I had to kind of pause, and I'm going to have to do this video in a third part. So this will kind of pick up where I left off. What I wanted to show you was this is how you get the differential. This is the approximation, and we got negative 0.3. But the way you can find the actual rate of change is just do this. So you can do the function value. Remember, the original function is 3 cosine squared x. And we can evaluate this, evaluate that, and then find the difference, okay? So if you look at this formula up here, that's kind of what this is saying is this is delta y, which is the exact difference between the function values, but it can be approximated by dy, the differential, which is f prime of x, okay? That's the whole key to what we're learning here is understanding that formula and how it connects to that diagram. So what I'm going to do then is we're going to put this in the calculator. Okay, so if I do this, I'll put this in like this. I'll go 3 parentheses, then I'll go cosine pi over 4, pi over 4 plus 0.1 to the second power. Okay, I'm going to do that. Then I'm going to do the second part, the function. So 3 times cosine pi over 4, and you got to be in radian mode when you do this, and then squared like that, all right? So if I put this in, okay, this is kind of what I was hoping would happen, okay? So we end up getting, that's about negative 0.298003999962. So what I want you to notice is this is pretty close to that. All right, see, it's close within like 1 decimal. Okay, so it's actually a really good approximation. And so you can use the differential to find an approximation. Okay. Okay, so I'm going to go to the next page and we'll start crunching out some differentials. And we're going to do some things. I'm going to add a couple of examples on here too that'll help you with your homework. So let's see, we're going to take the function, express a relationship of a small change, writing in the form f prime of x dx. Okay, so I'm going to go ahead and just start this one like this. So we're going to do dy. So what we're going to do is f prime of x times dx. Okay, and I'm going to write this function as sine of x squared. I'm going to go like this. So that derivative is going to be 2 sine x times the derivative of what's inside by the chain rule. And then you got to tack on that dx right there. So you have this. You have 2 sine x times cosine of x. Derivative of sine x is cosine x times dx. That's a good answer, but we do have an identity. Remember, the sine of 2x is equal to 2 sine, equals 2 sine x cosine x. Okay, so we could write that as sine of 2x times dx. That's it. Okay, we're not doing anything with that problem. We're just expressing the differential dy in the form f prime of x dx. So I think on your homework you got a few problems where you're just doing that, just doing the derivative and tacking on the dx. Okay, because you're doing dy, you're finding the expression dy. Okay, so I was going to add on a couple of examples here. Just a second here. Okay, well, I meant to record this problem, so I'm going to just go ahead. I don't think I recorded that. I had this on pause. So let me do this problem for you right here, and I'll run through this. Okay, so I got students coming by my office today needing help for tonight's test. So I keep getting distracted, which is okay. All right, so we're going to do dy. We're going to do f prime of x dx. Okay, so we're going to do a product rule on this. So we're going to do the first times the derivative of the second, and then do it backwards, plus the second, and times the derivative of the first. Okay, so it'll go like that. All right, so we have 2x. Remember the derivative, we're going to do this derivative and that derivative. Derivative of cosine is negative sine. And by the chain rule, we multiply by the derivative of what's inside to get 2. And then from here, we have plus cosine 2x. And derivative of 2x is 2. And I'll just kind of clean this up a little bit. These can go together. And then I'll write the answer as, like this, negative 4x sine 2x. And then I'll write this as plus 2 cosine 2x. Then you got to tack on the dx. Okay, and that's good enough. Okay, just remember to put the dx in there. All right, you got to do that on your homework. You make sure the dx is there. Okay, now I'm going to do 2 other things. I'm just making up some things that are kind of similar to what I assigned on homework. So we have y equals, let's say that we have 1 over x to the second plus 2 all over x to the second minus 10. And this time I'm going to give you x equals 1, and I'm going to give you the differential dx is a small number. I'll give you like 0.01. 001. Let's do that. Okay, so you'd start this off the same way. What you're going to do is dy is equal to f prime of x times dx. All right, so we got to do this in a quotient rule. So we're going to go ahead and start the derivative here. So what we're going to do is the bottom, x squared minus 10, times the derivative of the top. If I were doing the derivative of the top, I would write this as x to the negative 2 plus 2, and we do it backwards. And I'm just going to write that as x to the negative 2 plus 2, and then we're going to do the derivative of the bottom, x squared minus 10. Okay, so I've taken the bottom times derivative of top minus top times derivative of bottom, then I got to do all over the bottom squared. So the first thing is we want to do this, and then you tack on the dx. That's real important in this problem that you do that. Okay, so we're going to go ahead and complete this now. So that means after I got it set up in the quotient rule, I need to do these 2 things right here. Okay, so this is going to give x to the second minus 10. This part here would be negative 2x to the negative 3. Derivative of 2, of course, is 0. Then we have minus x to the negative 2 plus 2, and then times 2x. All right. Oh, I forgot to square my bottom. Okay, so that's x squared minus 10 to the second. Okay, so we have that. All right. Now we might as well just kind of multiply this out and see where this leads us. So we got a distributive property we can do. We can do that and that, and then that and that. Okay, so let's go ahead and complete that now. So we'll have negative 2, and see we're adding the exponents. Negative 3 plus 2, we want to do that would be x to the negative 1. Negative 2 times negative 10 is positive 20. We have x to the negative 3. And be kind of careful. You have 2x times x to the negative 2. Remember, that's the first power. 1 minus 2 is negative 1. So it would be minus 2x to the negative 1. And then this would be 4x. However, that minus distributes through to give you that then. And then that's all over x to the second minus 10 to the second. Okay, like that then. All right. Okay, so about all I see to do on this is we do have like terms there, and then that's good enough. Okay, so we'll just write this as, I'm going to write the 20x to the negative 3. Those things go together to make minus 4x to the negative 1, minus 4x, all over x to the second minus 10 to the second. Okay, and then don't forget to put your dx. Okay, it's easy to forget that as you're running through that derivative. So that's what dy is it's approximate, or that would be the expression that gives that then. Okay, now in the second part of the problem, what you're going to end up doing is x is equal to 1 and dx is equal to 0.001. And we'll have to use a calculator to do this, so we're just going to plug in here. Everywhere we see an x, we're going to plug in 1. And then everywhere we see a dx, which is one place, of course, we'll put in the 0.01. And let's just do this on the calculator. So I'll set this up. I have 20 times 1 to the negative 3 minus 4 times 1 to the negative 1 minus 4 times 1 all over, and then the bottom would be 1 to the second minus 10 to the second, and then times dx, and then dx is given as a small quantity, 0.001, like that then. All right. Well, you can do this as much as you want to on the calculator. Anytime you take 1 to any power, it's 1. So this would just give dy equals 20 times 1 minus 4 times 1 minus 4. And then the bottom would be negative 9 to the second. Then multiply by 0.001. Okay, so this looks like the numerator is 20 minus 4. Minus 4 would be 12. Denominator becomes 81. And then we're going to multiply by 0.001. All right, so I'll just do this with the calculator. Okay, so I'd go like this. I can go 12 over 81. I can just convert that to a decimal if you want to, like that, and then times 0.001. And then that'll give the approximation, which is about 1.481481,481, and that means times 10 to the negative 4. Okay, now if you were going to round this off, again, this just means scientific notation. The decimal would go back 1, 2, 3, 4 units. So you would get 0.000148, however you want to round that then, and that would be your approximation when x is 1 and dx is 0.001. Okay, so that's how that goes. Okay, so pause if you need to do that. I think I'm gonna just move down here, and I'm just gonna have you do one problem like on scratch paper or something, but you don't have to turn this in your notes. So pause if you need to, and I'll let you try to crunch through one of this. This is what you'll see on your homework. So, so we have example 7. Okay, I'm going to give you the function f of x equals x over square root of x plus 1. And I'll give you x equals negative 2. And this time I'll give you dx is 0.01. Typically, you're going to be given a pretty small value for dx. The idea is the smaller it gets, the more accurate you get when you find dy. So I'll have you find dy. Just kind of repeat what I did in the last problem. You should see a problem like this fairly similar on your homework. All right, so if you want to look over this, you can either have this answer or this answer. And I gave you this x equals negative 2, which is probably not a good choice because it would make this 0. You would end up getting 0, I think, as your answer on here. So I was going to change that to negative 3. Or actually, okay, let's use a positive number. Okay, let's say x equals 3. Sorry about that. I just sort of randomly picked a number on there, but you should get this or simplified like that. You may need to look over that a little bit, but let's finish it up in this form because it's a little easier. So we'll just plug in everywhere we see x, we'll plug in a 3. So we'll have 3 plus 2 over 2 times 3 plus 1 times square root of 3 plus 1. And then you multiply by the dx, which will be 0.01. So I picked a number that kind of works out nice. So that would be 5 over 2 times 4. This would be square root of 4, so that would be 2. And then times the 0.001 or 0.01. Okay, so that would be 5 over, and let's see, that would be 16 times 0.01, and then you just go to your calculator to get that. Okay, and I'll just do this like this. I'll just convert the 5 over 16 to a decimal, and then multiply by 0.01. and that'll give 0.003125. Okay, so that's what you're doing on that. You may need to kind of look over the derivative you did. I used the quotient rule. It'd be okay if you stopped here. I mean, that's an okay answer, and it's a little easier if you do what I did here. I ended up just getting rid of this fraction and ended up getting down there. Okay, so I'm going to explain one more thing. Pause this video if you need to do that. And I want to explain one more thing. I'm just going to do a problem that was on the assignment, and it said something about you have a cube. So I'm going to draw like a picture of a cube here, and each side of the cube, of course, is x, and then we're going to do something with the surface area. Okay, so really what a surface area is, well, you just do the area of each face. So you do base times height, so that would be x squared. Okay, so that would be what that is. So if you're going to do the total surface area of a cube, well, there's 6 faces. So that just means it would be 6x squared. Okay, so that's the surface area formula for a cube with side x. Okay. And what you're doing on this is you're just doing the differential. I think the problem that was, I wanted to go over in the homework, it was just saying find dA, find the differential for the surface area from x to x plus dx. Okay, well, that goes like this. If you go back to your formula, see what you're doing is you're looking at, if you're going from x to x plus dx, then you're just estimating that by f prime of x dx. So all you have to do on that problem is actually real simple. What we do on this problem is you just do this. So dA would be the derivative of this, which would be 12x times dx. Okay, so that's the idea. So what you're doing with that problem is you're just developing a formula for surface area, then you're doing dA, okay? So that's all you're doing. Okay, so I hope this will help you guys get this figured out. I've kind of had a really, really bad throat and cold, so I'm just now got back to a point where I can talk effectively again. So, all right, so that'll wrap us up on this then. So hopefully this will help you to get the rest of what your work done.